In this episode of the Backpacking Light podcast, we dive into the testing and performance of waterproof breathable fabrics, featuring an interview with Steven Sieber.
Look for me in the mountains where walking has a way of pulling you to your peace of mind every day.
Welcome to the Backpacking Light podcast. I'm Andrew Marshall.
And I'm Ryan Jordan.
And in this episode, we talked to Backpacking Light contributor and gear tester extraordinaire Steven Sieber about moisture vapor transmission rate, breathability, waterproof breathable fabrics, and some of the tests he's been running for Backpacking Light lately. If you like nerdy stuff, this is going to be the episode for you. But before we get to that, let's spend some time catching up. Ryan, it's been a minute and your life has been... Is exciting the word that you'd use?
You could say that. We had a bear enter our truck at this cabin we're staying at. We're living in a cabin interim. We're between housing right now. And so while we're waiting for the new place to be ready to move in, we've had to kind of piece together all these different options. And so right now we're staying at a cabin at about 11,000 feet in the Colorado Rockies. We have great internet. There's no cell reception up here, but it's very remote and it's really very peaceful. It's kind of nice, but there's bears and there's moose and there's just tons of both of them. And so shortly before we arrived, a bear and her two cubs ransacked the cabin owner's shop. They lifted up the garage door and went in and tore the place apart. And the other morning, we've been locking all our doors at night and everything. And the other morning, I went out to get something from the truck. Got it, came back in, and I forgot to lock the doors in the truck. But it was daytime, so I didn't think the little bandits would be active during the daytime. But I went back out a few hours later, and all the doors in the truck were open. There's very dirty paw prints all over our seats and saliva everywhere from where they licked stuff and tried to find stuff. Of course, we didn't have anything in there, so they didn't do any damage. But it was pretty exciting, and they left a calling card on the back of my camper with a paw print. So we knew who was at fault, but we never caught him. So now we have to lock everything all the time. And it's just one of those things, but it's been an interesting and fun experience up here.
Yeah, we have a lot of bears here in Tahoe. And I think it's fascinating how they always open every door of the car. Something about that cracks me up. Yeah. And, we've had a bear in our car one time, and it was the one night that I forgot to lock the car doors. And so what that tells me is that they go from car to car, house to house, trying the doors every night. And I just find that incredibly fascinating.
Yeah, there's YouTube videos all over showing trailhead parking lots and campsite parking lots in the Sierras where the bears just go from car to car and test things out. It's pretty funny.
Well, what kind of gear have you been looking at lately? Have you had time to look at anything interesting?
Yeah, I picked up a new pack. It's the Arc'teryx Aeros 45, the new model, the 2021 model, I guess. And it's a really interesting backpack because it kind of goes away from the classic internal frame metal stay or hoop kind of frame system, but it still has a frame sheet in it. And in the past, I've always considered frame sheets to be not quite internal frame, so more frameless with some shape and stability. This one goes a step further by incorporating these reinforcements in the frame sheet that actually give it a pseudo frame behavior and provides a lot of stability as a result. And so I've been able to pack it with some pretty heavy loads, much more than I thought I would be able to do initially. So a frameless pack for me, it starts to poop out at about 15 pounds before it just starts to be uncomfortable for me. And so adding a frame sheet, whether it's, a really stiff foam or a piece of plastic, I might be able to get another 5 or 10 pounds out of that. But this one I can load to 35 easily and it still maintains some comfort and prevents that torso from collapsing. So it's been a really interesting product. It's a roll top pack, but the roll top can stay shut and you can still access the inside compartment. It's got a full length vertical zipper.
I love that.
I do too. I didn't think I would like it, but it's proved significantly more useful than I thought it would be. It also has these massive side pockets that can be loosened with draw cord and toggle. And so you can actually access everything in there while wearing the pack without, having to dislocate your shoulder. So I like that feature. Great waterproof, durable fabric. It's a little over 2 pounds, so definitely heavier than ultralight, but worth a look if you're looking for kind of an innovative 45-liter pack for weekend travel, especially one that's could be nice for really wet conditions.
Yeah, Red Paw Packs, when I reviewed one of their packs, they've got the roll top with the full-length waterproof zipper down the vertical line of the pack, and I found it way more useful than I thought it was going to be. I was using it almost exclusively to get in and out of the pack. What's the frame sheet made out of in this Arc'teryx pack?
It's a thermoplastic, and then I haven't dove into the technology for the reinforcements, but appears to be just, a different density of plastic of some type.
Well, I've been looking at NEMO sent me a new version of their Tensor sleeping pad, and this version of it's going to be available in spring of 2022, but I am allowed to talk about it. And I used it on my recent 12-day backpacking trip in Colorado. And so the main thing that they've done on both the insulated and uninsulated version of their pads, of the Tensor pad, is increase the R value, but they've retained the same weight as their pads were previously. And they did this by rearranging the baffle system a little bit.
So to minimize air exchange between baffles, or what do you think?
Yeah, that's my understanding. I've been chatting back and forth a little bit with the engineers at NEMO and haven't quite, gotten to exactly what they've done. But, so the old R value for the insulated version was 3.5. Now it's 4.2. I don't know if that's enough of a difference that you'd actually be able to feel that in the field or not. I was backpacking with a guy who was using the old version and I had the new version. And so I tried to do as much comparison as possible every morning to see how he slept. But I mean, there's so many variables there. It's almost stupid to even try. But I will say, if they measured them the same way, if they did the same ISO, standardized test, which I'm assuming they did, it is, by the numbers, slightly warmer.
Well, we'll take it if we can get a few more degrees without adding weight. That's great.
Well, that being said, I think that conversation we just had kind of gets into a little bit about what is on paper and what you can feel in the field, which we touch on a lot in this interview that's coming up. So, Ryan, why don't you kind of give our audience a little bit of a introduction to who we're talking to?
Steven Sieber is a Backpacking Light community member who has historically had an avocation in the area of materials testing, and he now has a material testing lab that focuses on outdoor performance apparel, insulation, sleep systems, things like that, focusing specifically on outdoor industry, insulation and moisture transmission through fabrics and garments. So without further ado, let's go to that interview. Okay, everybody, we are joined today by Steven Sieber, a regular Backpacking Light contributor and gear testing aficionado. Steven's focus is on material and fabric testing, especially when it comes to things like waterproofing and breathability performance and just the general kind of tests that go into evaluating the comfort of apparel and insulated garment and sleep systems. So, Steven, thanks for joining us on the podcast.
It is my pleasure.
Steven, can you just tell our audience a little bit about your background in the industry and what you are doing now for Backpacking Light?
Sure. I really have no background in the industry. I operated my own business that did testing for almost 40 years, thermal, all sorts of mechanical and structural testing, and the objective was to evaluate problems and solve those problems through re-engineering, although I am not an engineer by education, but perhaps by avocation afterwards, as part of everything I've done throughout my career. I sold my testing business in 2017 and retired, and on January 1st of 2018, we drove out to Colorado to see if we wanted to live here, and we concluded we did. So we sold our house in Maryland and moved out here during 2018, and we've both been delighted. My wife and I have been totally delighted with our decision ever since. We will not be returning to the East Coast. When I had my testing business, I was always interested in doing clothing testing, and had a number of clients who paid for typically infrared-based, thermal-based evaluations of their products. And that expanded somewhat as time went by, but I never really had the time or demand to devote a lot of resources to expanding that area of interest. But when I came to Colorado and wasn't working anymore, I found that I had plenty of time to pursue whatever interested me. And so and at the same time, I discovered backpacking light, and found that I had been I've always done a lot of hiking in the mountains on the East Coast. And my approach was to go up as fast as I can, and then come down as fast as I could. And in the process of doing that, I would soak out my clothes, and I would get to the top of the mountain where it was cold and the wind was blowing, and I would change my clothes in the cold, and thinking there must be a better way. And through backpacking light and studying a lot of what's on the website, I found that there was a better way, and sort of transitioned in that direction, totally transforming the way that I dress for my outdoor activities, summer and winter. And at the same time, I started pursuing increasing my range of testing abilities with clothing so I could figure out what I wanted to wear and what serves my needs the best. And as I progressed in that, then I started posting articles about what I was doing. Not articles. I would write papers and just post them under the gear section, and then get involved in some of the discussions. So I've been working on developing my capabilities and expanding them for 3 years now, and testing a lot of fabrics and insulations and tent fabrics. So it's a fascinating subject, and unfortunately, it's a subject where the consumer often doesn't really know what they're buying, because the proper descriptive numbers aren't on the label anywhere. And a lot of the reviews that are published online or in magazines, if we can still find those, they're qualitative. They're personal assessments based on wearing an item for an activity. If you have access to the descriptive numbers that actually objectively quantify what a reviewer is trying to describe, you can find that often people's concept of breathability or warmth, they fly in the face of reality, because these changes can be very subtle between garments and very hard to perceive throughout a pretty broad range of activities. By the end of the day, you might have a good feel because you're soaked inside or you're cold or whatever. But with the use of quantitative testing makes it a lot simpler to try and get a handle on what your experience is likely to be out in the field under different weather conditions and exertion levels.
We're going to talk about the relationship between those numbers and what we experience in the field in a little bit. But first, I want to address the comfort of a performance apparel system. is in large part, you said you were experiencing soaking out your clothes. The comfort of a performance apparel system is in large part the ability for that apparel to manage moisture. I'm not going to say remove it entirely, but I'm going to say manage it. So what are the mechanisms by which the moisture at the skin surface caused by perspiration, for example, gets out of your clothing system? Let's walk through those processes.
Let me just back up to what you were and address something that you just mentioned, that we rely on our clothes to control moisture. Well, that's true. We do, but clothes always have limitations in dealing with moisture. You can always make moisture faster than your clothes are going to get rid of it. So if you expect your clothes to manage moisture under all circumstances, you are going to be disappointed with your clothes, and you're going to think, well, this doesn't work. I need to try something else. Well, in reality, what you need to do is understand the limits of your clothes, understand the demands you're putting on your clothes because of the environmental conditions, and the demands you're putting on your clothes because of your level of effort. All of these things have to be in balance in order to control moisture. And if you're not controlling moisture, you either have to control your environment, which is kind of hard, or your level of activity, which is a lot easier to control. So when all else fails and you're wetting out your clothes, you got to take something off, or you got to slow down, because your clothes simply cannot do it all. Okay, so having said that, your body releases moisture through three mechanisms. One is breathing. When you breathe, moisture in your lungs is released to the atmosphere. Another source of moisture, of course, and the main source that we're concerned about, is sweating. As we produce more heat than we need for maintaining our core temperature, the body will start to sweat to try to eliminate heat. And the way sweating eliminates heat is through evaporation. If you sweat and the sweat doesn't evaporate, it's not going to cool you off. Every pound of sweat that comes out of your body, when it evaporates, it sucks 1,000 BTUs per pound of sweat from your skin. And that is a lot of heat. And that's why sweating is so effective, as long as the sweat can evaporate. If the sweat goes dripping down your clothes and ends up in your pants, it's doing you almost no good, because it's not evaporating, and you're not getting that big chunk of BTU loss that happens when sweat goes from moisture, from water, to vapor. So that's the main cooling mechanism. The third source of heat is moisture that just oozes out of your skin. It's insensible perspiration, and you can't really control it. It's relatively small compared to the moisture released by sweating, but if you're in a garment for a long time, not moving, it might accumulate. Certainly that's going to happen when you spend the night sleeping in your sleeping bag. Even if you're not sweating, you're still releasing moisture into your sleeping bag. So we'll concentrate on sweat. So when you're sweating, your skin can get wet. Your skin will get wet, and you want to carry that away from your skin, which is sort of in contrast with what your body really needs to cool off, because as moisture is moving away from your skin in liquid form, for example, through a wicking layer, it now moves farther from your skin, and eventually, to get rid of that, it has to evaporate to move through your garments and out of your outer shell. Otherwise, you're simply wetting out your clothing. So it has to evaporate to escape, which means that you're losing the effectiveness of your cooling, because as the liquid moisture, as liquid sweat moves through your garments, through wicking, it's now picking up some of its heat, possibly from the environment or possibly from you. We don't know where. It's a very complicated process. In fact, as moisture moves through your layers, through your garments and out, it has the opportunity to condense, to evaporate again, then condense again, possibly freeze when you're out in below freezing temperatures and it hits your outer layer. And once it freezes, then it's really hard to get rid of if it freezes in your layers. So that's a real problem. You never want to reach the point where that's happening. And in cold temperatures, it's hard to avoid that because as the temperatures that moisture leaving your body encounters get lower and lower, the vapor that's been formed reaches something called dew point, where it condenses again. And then if it condenses against something that's below freezing temperatures, then it'll just produce frost on that surface. So when you're in that situation in very cold weather where that can happen, you need to be very careful about the opportunities. You need to be concerned about the opportunities you provide for vapor to get through that final barrier. And if it's cold enough, that will often not be through vapor transmission through the surface. And then you need to rely on venting to keep the moisture level down. If you keep the moisture level down and it can waft out through air movement, then you can avoid the inside of your outer layer freezing up. So in the past, I was speaking about my pre-backpacking light past. I had an interesting experience where I was hiking in Virginia in a snowstorm, and the temperatures were around 30, and so the humidity was very high. And eventually, of course, as was always my want, I sweated out my garments and had to stop and change my base layer. And when I did, I took my GORE-TEX jacket off. It was kind of a struggle to get out, and I put it on a picnic table that I encountered. And there it was, just a solid board of GORE-TEX, frozen solid from frost on the inside of the jacket. It can't possibly go through under those conditions of cold and high humidity. There's not enough vapor pressure differential in those conditions to drive anything through the garment. Plus, you have the cold temperatures that are making the moisture freeze as soon as they hit that very cold surface. And that's something that never happens to me anymore. And we can talk about what I'm wearing for my needs that prevents that kind of what appears to be a fabric failure or a garment failure, but isn't. It's an operator error when that happens.
You used a couple of phrases there that I'd like you to define, because I think there's some confusion and people tend to use these two things interchangeably. Can you just define moisture vapor transmission rate and air permeability and tell us how those two things are different?
Okay, sure. Air permeability describes the ability of air to basically blow through a fabric. And moisture vapor transmission rate describes the ability of vapor to pass through. So they're sort of similar, but the mechanisms are very different. Vapor is pushed out, pushed through a jacket by something called vapor pressure differential. So where you have high temperature and high humidity, the temperature is forcing the vapor to expand. It wants to move. And if on the other side of a piece of fabric you have low temperature, low humidity, you can actually calculate a pressure for that combination because the vapor is exerting pressure against its environment. You can calculate and measure pressure for vapor wanting to move, just like you can measure pressure for air wanting to move. And you can use the same units, for example, pounds per square inch. And so the force that moves vapor is vapor pressure differential. The force that moves air is air pressure differential. So if you have, say, a 20-mile-an-hour breeze blowing against your jacket, if you look, you might, and if you're standing still, that might exert a pressure of around 0.4 psi. If the wind isn't blowing, then there's almost no pressure on your jacket. There's basically no pressure. So if we have the condition where wind is blowing at 20 miles an hour, and we have a fabric where the weave is not terribly tight, or it doesn't have a waterproof barrier on it, then air can potentially blow through that jacket. If you take that jacket and you hold it at arm's length between the wind and you, then the wind will blow through that easily because of that pressure differential. If you take that jacket now and you put it on and you zip it up, now the air has a much harder time blowing through it. So when we measure air pressure, the way it's done, it's similar to holding your jacket out at arm's length. You take a piece of fabric. Should I show you what this looks like, the test looks like?
Okay, so for those of you who are unlimited members and have access to the video version of this podcast, we'll put up some visual aids on the screen that Stephen will walk us through as he goes through the process of testing air permeability.
I'm describing how air permeability differs from vapor permeability and the driving forces between the two that are very different. So if you take a jacket in a 20-mile-an-hour wind, take it off, hold it in front of you, the windward side experiences high pressure. The leeward side, the side facing you, faces low pressure. And so air can move pretty freely through that jacket. And that's sort of how we measure air permeability. So what I'm showing on the screen is the air permeability tester that I built. We can see a piece of fabric that's sitting on a duct, basically some cylindrical tubing, and air gets blown through this sort of like holding the jacket out towards the wind rather than wearing it. All right. So, and the way this device works is that we've got these air volumetric testing devices. When air blows through these, they can measure cubic feet of air flowing through them, which then flows directly through this duct. These things with these knobs, we can adjust the volume of air that's flowing through. The way this test works is this is a manometer. It's a digital manometer. It measures pressure. We adjust the volume of air blowing through the appropriate metering device until we get a pressure differential from the bottom of the fabric to the top of the fabric that's equal to 0.5 inches of water column. Then, it's very simple. We read the velocity of air that's going through. I know the diameter of this opening, and so I use a simple conversion factor to go from velocity to volume, cubic feet per minute per unit area, for which is a foot squared according to the standard that's used. So it's a very simple process, as many of these tests are. This test is analogous to holding the jacket out in front of you, because there's a pressure drop, a dramatic pressure drop from one side to the other, and the air is free to flow without obstruction through the fiber, through the fabric, and out the top of this device. Now,
okay, so I want to clarify something here. If you're testing multiple different fabrics with different air permeabilities, the differences in what is measured in those fabrics are different velocities at constant pressures. Is
that's
that right?
Correct.
Okay.
Yes, that is right. And of course, there's a very wide range, and I encountered them all with this device. With this device, I can measure up to about 700 cubic feet per minute down to just about zero. After 700, I can't maintain the pressure anymore. I would need a much bigger air source to make it work. And there are very few garments that will ever operate higher than 700 that you wear, although I do have some. Okay, so now in terms of what these numbers mean, when you look at an air permeability number, it's calculated at 0.5 inches of pressure, and it assumes the free flow of air from one side to the other. So the air can flow out of this measurement system without any restriction or obstruction. When you take this piece of fabric and you turn this into a garment and you're wearing it, that's no longer the case. Because now, when the air is trying to blow through this, what does it encounter? It encounters you. And it not only encounters you, but in order to encounter you and then leave, it has to escape the garment somewhere. And if everything is zipped up and there's no easy way for the air to go out, then it's likely, it's certain that whatever you think the flow of air should be for a particular pressure difference or a particular wind speed, that's not happening. The airflow through the garment and its ability to remove heat and moisture will be dramatically lower than what would be the case if we were just looking at air moving straight through with no further restrictions.
Let's walk through a hypothetical extreme scenario that's not necessarily super practical, but if you were wearing a garment that had low air permeability, a wind shell, for example, and you were comparing that to a garment made out of no-seam mesh, would the massive air permeability that the no-seam mesh allows, even when worn against the body, that would allow some air movement to spill heat and moisture from your system, right? Because the air can go into the no-seam mesh and back out through it quite easily.
Well, maybe. I would expect, first, so as long as that no-seam mesh is loose against your skin, then that's going to happen. If the no-seam mesh is tight against your skin, that's a different story, because now we don't really know how easily the air can move through and circulate around. So certainly, to the extent that if the mesh is large enough, you're going to have skin exposed to the moving air, and you will cool. Right. But if you go to a tighter and tighter mesh, at some point, you're not going to notice a cooling effect.
Yeah, especially if you are layering a wind shirt, for example, over one or more other layers.
Yes, that's right. Yeah. So the more impediments to air movement, the easier you make it for air to get directly to your skin and to actually move across your skin, the more effective that cooling mechanism will be. but that's not actually an easy thing to achieve. I mean, believe it or not, in the summer, I wear 2 shirts. One is 400 CFM. So sort of what everyone thinks is a lot of air movement is a Patagonia air shed, the old air shed. Okay. The present air shed stuff is not quite as permeable. And I don't remember the exact number offhand, but it's probably 50 CFM. And people think this is a lot of ventilation. I say 50 CFM is not a lot of ventilation. I say in the summer, if you want to really get some cooling walking around when it's hot and possibly humid, I don't really know what humidity is anymore, but I think between 400 and 700, that's a pretty good number. 400 and 700 CFM per square CFM per square foot is a good number if you want to really get cool at walking speeds. Now, once the wind starts blowing, it doesn't even have to blow too hard, but if you have a 10-mile-an-hour wind, that's going to make a big difference. But if you have no wind and you're just relying on the pressure of your forward momentum at 2 or 3 miles an hour, there's no pressure. And so you really need a huge amount of air permeability to get cooling under that condition. All right, so we're walking forward and we're relying on air permeability through even an air shed to keep us cool. And I've sort of described why that's not really going to happen, because the air pressure, the driving force to try to get ventilation going through your garment at 3 miles an hour is a tiny fraction of a PSI. It's basically nothing. Right. Now let's consider vapor pressure. Vapor pressure has nothing to do with airspeed. What it has to do with is the humidity and temperature conditions against your skin and the humidity and temperature conditions in the environment. And those are much bigger pressure differentials. That's a much bigger pressure differential than you'll experience from air pressure when the wind's not blowing and you're walking at 2 or 3 miles an hour. So that's why when there's no wind blowing, you can still get rid of a lot of sweat if you have a garment with high moisture vapor transmission abilities. And the reason that I don't get frozen jackets anymore is because I'm very cognizant of the vapor transmission abilities of everything I'm wearing. And I know when the conditions will not permit that system to work. And I know what to do to avoid that problem, which is...
So you regulate insulation and energy output.
I change layers constantly as needed.
Yeah.
A lot of people, I get the impression, don't like to stop and change their layers.
Right.
So,
most of us are pretty lazy.
Right. So I did, some years back, I hired a guide to take me up to the top of Mount Washington in New Hampshire in the winter. And for any of you who have ever been there, you know that you have to hold on. Once you get above tree line, you have to hold on to anything you can. If you take a step without putting your pole down to brace yourself, you're going to get blown over.
Yeah, Mount Washington has the highest recorded wind speed on Earth.
That's right. And and when the day that I went to the top, it was only around 60 miles an hour, which is not much for up there. But what I noticed this guy doing, he stopped all the time to change his layering, all the time. So he would never let himself sweat. He would always have the appropriate clothes on, whatever he needed. And he took the time to do it. And he was never inconvenienced by sweating out his clothes. When I got to the top of that mountain, my clothes were soaked, and I had to find some shelter from the wind and change for the descent, which is always pretty uncomfortable. So, I think part of the owner-operator responsibility is that you need to be cognizant that when your clothes aren't working, you need to change your clothes, and you're going to have to stop and lose some time. But I think ultimately you'll be better for the time spent making sure that you're not exceeding the capability of what you happen to be wearing at the moment.
Well, I was just going to ask, so you mentioned so that you're always looking for high moisture vapor transmission rate garments now. So what to you is a high number, and how does that number differ from when the manufacturer, gives you that number, and maybe what are some of the things that you've measured?
Okay. Most but not all of the manufacturers that list such information will use a standard called JAL 1099. It's a Japanese standard. And that standard actually has 4 different variations. And each variation can produce a different number. The one that is most typically used for looking at waterproof breathable garments or waterproof garments is their B1 variation. And so when you see numbers 20,000, 40,000, 60,000, 80,000, 80,000, I've seen one that claimed 90,000. That would be pretty nice if that existed, but I don't know if it does. I mean, that product I've never seen on the market. They were, in any case, the other main competing standard is ASTM E96, I believe it's called, and that might come up with numbers like 1,000 or 800. It's much different, and it doesn't mean that these garments are performing any differently. It just means they're being tested with something that changes there will be moving air in these standards. Still air offers a lot of resistance to vapor transmission. If you have an air layer involved in your test process, it's going to lower the numbers. The pressure that you can create across the garment that you're testing will vary according to standard. So if you can have higher pressure and no air, you're going to get a big number. And vice versa, if you have some air trapped in the test and you're doing nothing to artificially increase the pressure, then you're going to have a lower number. It doesn't mean that the performance is different between the two standards. It just means it's being measured in a different way. So if you're measuring consistently, you will be able to make the comparisons between garments and fabrics that you're interested in. And the key is consistency. So if everybody tested and then listed their JAL 1099 B1 data, there'd be no need for what I'm doing. But that's not the case. So I have created my own, let's see if I can get there, my own method, which I sort of call the permeation kettle method, because I call these things permeation kettles, and people who read my articles have seen plenty of examples of this. All right, so here we have my permeation kettles in the configuration to measure moisture vapor transmission rate. In the top photograph, we see 2 kettles, and each one has a different waterproof, breathable garment fastened on top, and that's what it looks like when the test is being run. Now, if we remove the jackets we can see what makes this happen. So in any of these test methods, you're interested in forcing water vapor through a test fabric and having some way to keep track of how much water vapor has actually escaped the system. And so this is how I do it. When we look, these kettles are filled with water, and I heat them to a particular temperature. The temperature that I start the test at is my guess as to what will allow me to meet my set points for doing the test, temperature and pressure set points in a particular time frame. And if it doesn't make that, then I'm going to allow the temperature of the water to change until I can make those set points. And that can be a time-consuming part of the test, but of course I've gotten better over time at guessing where things are going to come out and guessing at where my starting point should be. My starting point in the water with the water temperature is 105 Fahrenheit to 120 Fahrenheit, and that covers pretty much everything that I've come into contact with. So here's the way it works. I take 100 grams of water at 120 degrees, and I put it in this white tray. Above the white tray is a sensor, it's a sensor that measures both humidity and temperature, and it sends that information to my control program, and the control program takes over the function of controlling the temperature in the kettles. So what happens is in fact, all of the standards that are out there, they're set up for a particular set of ambient temperature and humidity conditions and a particular wind speed. And the water, however it's presented, is also maintained at a particular temperature. And what that does is it predetermines a vapor pressure differential across the test. When I first developed this test, I didn't have an environmental chamber, so I couldn't really guarantee what my temperature and humidity conditions were going to be. So I designed this test so that it would maintain a specific vapor pressure differential between what's under the garment and the environment outside of the garment. And I've always used 0.3 PSI as that pressure. So this test works different than all other tests in that this test operates to maintain a pressure differential across the garment, which in principle freed me from the needs of environmental control. I now have environmental control, and so now I can maintain the conditions in the test room within close to 1 degree Fahrenheit during the test, which improves repeatability of the test. But that's the genesis for this design. So we've got the sensor above the water, above the 100 grams of water, and then here is a little fan. And the fan causes the air to circulate when it's covered up. And turns out having that small amount of air circulation has a substantial difference on the numbers that the test generates. It raises them up quite a bit because the still air, as I mentioned before, offers a lot of resistance to vapor transmission. And so if we look at this, we've got a pretty good air layer below the bottom of each test jacket. It extends obviously from the bottom of the jacket to the top of the work surface on the kettle. So it's a lot of air, and so it made a big difference once I started circulating the air in the absolute value of the numbers. That's not to say that this test would be any less useful if I eliminated the fan. So who knows? It's a decision I made, and so I've kept this configuration since. And what's important as time goes by and I test more and more garments is to have a fixed test bed without a lot of changes to the test method. So there may be other better ways to do it, but they may not produce an answer that's any different. In fact, I have now developed a correlation that allows me to convert the numbers that I create using this method to the numbers that you would get with the B1 test. And I've developed that using Montbell publishes these numbers on their website. It's fabulous. And I've tested their garments and use that to develop a correlation between my numbers and theirs. And it's a very linear relationship, and the correlation coefficient for those who are concerned about such things is 0.9957, which is a very straight line.
And that's a testament to an effective test method. Is it sensitive enough to measure the differences between the garments? And I think the test method is almost irrelevant as long as those correlations are effective and all the tests are trying to measure the relative differences.
That's right. And I think being able to produce this correlation between these two, between a very widely accepted test and my test, is sort of testament to the reliability and repeatability of both methods.
Yes, correct. I have a question
sure.
for you. If on the JAL test, if you have a garment that measures 20,000 and you have another one that measures 60,000, does that mean that the garment that measures 60,000 is 3 times more breathable than the garment that measures 20,000? And will you notice that threefold effect in the field?
I guess I don't know.
I don't either. That's why I'm asking you.
I will tell you my experience. So before I was wearing the shake dry, well, first of all, after I started reading Backpacking Light, I did what probably everyone does. I went out and got a Patagonia Houdini, and it was great. And then I continued reading, and the Houdini Air was introduced, and I wore it. And all that happened was, so my gauge of what's comfortable, as I'm doing an ascent, and it's 20 degrees, I'm going to be sweating out my heavy base layer in the winter. And what I found was, when I went from the regular Houdini to the Houdini Air, which has, 20 or 30 times the air permeability, I had to take that Houdini Air off at the same time I would the regular Houdini. And so it became apparent that the air permeability wasn't making much of a difference. And the downside was that as soon as the wind started blowing, and it was already 20 degrees, I was cold with that jacket on because it didn't stop enough air. All right, so then next I went to a Versalite, and the benefit of the Versalite was that it had pit zips. So that broadened my comfort area. But then I went to Shake Dry, and with Shake Dry, I could wear that base layer and I could go up the mountain with no wind at 40 degrees, and I was not sweating out. I was not wetting out my heavy base layer. And so the answer to your question is, under the right circumstances, you absolutely can distinguish perhaps not small differences, definitely not small differences in MVTR, but large differences in MVTR, absolutely positively. But again, you need to be aware that at some point you will overwhelm the MVTR of whatever you're wearing. And it's not the fault of the material. It's just the limit of the material. All these materials have limitations and trade-offs. And if you're going to be comfortable in the out of doors, and you guys, I'm sure, always are, because you figured this out over many years, you have to understand the capabilities and the limitations of each layer that you're wearing, and change it to be appropriate for the conditions and your level of activity.
I just want to clarify that Shake Dry is a GORE-TEX fabric, not a jacket brand, correct?
Correct.
Yeah.
Yes.
And so that leads me into the question of which different fabric technologies provide the highest moisture vapor transmission rate, and why?
Well, Shake Dry, if we're talking about waterproof breathables, Shake Dry is the absolute winner. I have seen nothing like it. Interestingly enough, the next closest jacket, and this is going to be discussed in the article to be published next month. The next highest MVTR waterproof breathable is the Precip Eco, is not much lower. It's pretty remarkable. And I don't know, what their membrane technology is, but it's very impressive, and it's very cheap. So, and it produces a jacket, the Precip Eco rain jacket. It's 10 ounces, just over 10 ounces. It's got pit zips. It's got all the features you want. It's still lightweight. So it's pretty interesting. After that, things start to drop off pretty rapidly. Actually, right below that would be Neo Shell, and the Neo Shell similar fabrics, Future Light and Ascent Shell. So those can range between 28 to just over 2,800 to just over 3,000 on my scale. And then below that, next will be GORE-TEX type fabrics. The most breathable is Pro. According to them, the most breathable is Active, and I guess that's possible. Their Active membrane, then their Pro membrane, then their GORE-TEX membrane, and then below that will be Pack Light. And of course, for those GORE-TEX fabrics, the actual moisture vapor transmission that you experience is largely a function of the face fabric that is bonded onto that membrane. The heavier the face fabric, the less breathable that GORE-TEX is going to be. So you can get GORE-TEX garments that have really mediocre moisture vapor transmission, and you can get some that have pretty good vapor transmission, and a lot of it, that is largely a function of the weight of the face fabric rather than the performance of the membrane itself, with the exception of Shake Dry.
Okay, that brings up a really interesting thing to me. If the membrane is not controlling MVTR and the face fabric is, and we're adding, and you're suggesting that heavier face fabrics result in a lower MVTR. Is that because of the construction of the face fabric, the type of bonding that's used, or some combination of both, or do you know?
Well, what I don't really know. I've always been curious about how the adhesives used to bond the membrane to the face fabric affect transmission, and it's not something that I can measure. And what I I can do and have done is taken a variety of Gore fabrics or fabric and membrane combinations and tested them. And so I can see that the weight of the fabric, the denier of the fabric, which is basically the weight of the threads used to make the fabric, has a striking effect on vapor transmission. So however they make these phase fabrics, they offer a lot of resistance to vapor transfer as they get heavier. Now, could this be changed? Sure, it could if they used a more open weave. But the manufacturers make their own set of trade-offs to get the performance that they're looking for. And if you use an open weave, I don't know. I could see how that could be beneficial because it will, even with an open weave, it will remain windproof because of the membrane. So you're looking for a face fabric that offers the ruggedness and durability that you need for your activities. So if you're rubbing against rocks and you're rubbing against vegetation, if you're bushwhacking, then you need a fairly robust fabric to avoid abrading and ripping your fabric. But I would think if you're not doing those things, then you can get away, I would think you could get away with a loosely woven, lightweight fabric because you're not going to need, you need enough durability at that point maybe just to withstand friction from your hip belt and pack straps. So, you know, right. So I don't know if there are other ways to achieve this. There may well be, you know, it may be that different phase fabrics could give you the protection you need for the membrane and give you the durability that you need for many activities. So you could have the protection and you could maintain your MVTR in principle, but it's not.
Yeah, I know the heavier fabrics also combined with DWR have more robust and durable waterproofing. So that might be an issue as well, because the tighter the weave, the more durable your water repellency is going to be. That's
a good point. And so, you know, to answer your question, you know, the phase fabric has an effect, and what can be done to mitigate that? So far, the only thing that I've seen is going to a lighter phase fabric. And the DWR point, it's an important one. A lot of people seem more interested in making the trade-off to have excellent DWR performance rather than MVTR performance. And that may be because they live in places or their activity levels are such that they're not producing that much moisture. And that's a fine trade-off to make. And I live in a place where DWR is not that important because it doesn't rain that much and it rains relatively briefly. So, you know, I may be very pleased with my DWR performance, but, you know, I'm not exposed to the conditions that someone backpacking in Tennessee, for example, might be.
Right.
The choices that people make are often obviously relative to what they're doing and where they're doing it. And what sounds crazy to me is absolutely sensible to someone else because their activities are different.
Yep, that's absolutely right. I want to shift gears a little bit to an announcement that Gore made this week with a new membrane. I'm going to call it chemistry. They launched an EPE-PU membrane. And the goal of this was to provide a membrane that was PFA-free. PFAs are chemicals that accumulate in the environment at somewhat toxic levels in water and can cause some issues with human health. And so there's been a push over the last several years to eliminate PFAS from DWR treatments, as well as, Teflon. They're present in Teflon, and GORE membranes are essentially a type of Teflon membrane. So I don't know if you know the answer to this, but do you I know that there's a relationship between the presence of PFAS in DWR and the effectiveness of the DWR. A PFA-based DWR is really, really effective. You know, if you look at a C8 DWR, then you go to a C6, which has lower toxicity, and it is definitely not as durable. Do you feel, or do you have a sense of whether or not PFAs impact the quality or performance of a waterproof breathable membrane?
I have no idea. So GORE is not looking to be PFA free in their garments. Right. They have created, I think they have coined their own term, but they're PFAs that accumulate in the environment. And they distinguish that from PFAs in general. And I have no comment on any of this, except that who's deciding what is harmful accumulating in the environment? Is it GORE or is it some other authority? And I think that for this initiative, I don't really know. And I tried to look at their patent, because they are prodigious producers of patents. And so if you can find the patent amongst the zillions of patents they have, then you can learn something about the product. I haven't been able to find the patent so far, so I haven't been able to read about it. But one of the Gear Junkie wrote up a piece that was a little more detailed than others that I've seen, most of which just seem to copy whatever was released by GORE. But Gear Junkie said that the RET value is 13. Now, let me just briefly explain what RET value is. GORE does not use MVTR tests for evaluating their product. They use a method called the sweating guarded hot plate. So it's a hot plate like I use for evaluating insulation performance, and that's one of the things that this thing can do, but it also has a layer of water that they evaporate through whatever they're testing. And I won't go into the testing process. It's somewhat complicated, but what it measures is a resistance to vapor transfer. So their published number, their RET for shake dry is 3. Their RET for Packlight, their standard GORE-TEX membrane that they just call GORE-TEX is also 9. Packlight Plus is 9. Pro is a RET of 6. So in this Gear Junkie article, and by the way, nothing is ever simple. That doesn't describe, I don't believe, what will happen with a finished GORE product. Right. I think that refers only to measuring the naked membrane, which of course you don't buy, and hopefully you'll never see it, because if you've seen it, if you're looking at it, you've probably ruined your jacket. So the GORE product that you buy, its RET number will be much higher. The RETs, the higher the number in RET, the worse the vapor transmission will be. So it's the opposite of MVTR. It's the reciprocal of MVTR. All right. So to get back to the point I'm trying to make, the Gear Junkie article listed a RET of 13 for this new membrane. So I am skeptical that if you're concerned about MVTR, that this will be the solution that we want to see. So I can't vouch for where this number came from. I sent an email to the author of that article, and maybe he'll let us know where he got it. But I presume it came from Gore. But it's kind of surprising they would come out with a whole new product, which I presume is intended to replace what they have, but it will probably cause a significant decrease in MVTR capability of the product. Also, when they say that it's of a much lighter membrane material, it's not as thick, I'm not sure why that matters, because the current GORE-TEX membrane material, it's, well, if you use Teflon tape to wrap around a pipe, that's sort of what it looks like, and you know how thin that stuff is. So if it's half that thickness, it's just not clear to me why that's going to make a difference. And, I could be wrong. I haven't seen any of this stuff. So, I think the judgment will have to wait until products start emerging. And I think that's supposed to be next year. From what I know of GORE-TEX, which is incomplete, if you put an active membrane on a low denier fabric, that can be a very nice jacket. But I've only seen one example of that, which is the, what is it called? Let's see. Okay, Mountain Hardwear Quasar, which is a 14 denier face fabric and an active insulation. And that beats out any implementation of Gore Pro that I've seen. I measured 2840. So it's pretty good. If you want more durability than a shape dry might offer, that's pretty good. Now, here's a question for you guys. This thing doesn't have pit zips. It has pocket zips for ventilation. Have you experienced ventilation through pocket zips?
Not when a backpack hip belt is covering most of the pocket, no. And the other issue is you're moving your arms when you're backpacking, especially if you're a trekking pole user, and pit zips are way more effective at spilling heat. The problem with pit zips, where that pocket zips tend to solve, is that shoulder straps of a heavy pack block a lot of the chest air movement inside, the bellows effect inside your jacket. And so pit zips help deal with the side of your body, but not the front of the chest. And that's where pocket zips can be helpful. I actually had a jacket years ago. It was made by Feathered Friends. It was made out of Epic fabric, which was a silicone impregnated polyester. And it had both ventilated pockets, big, huge, wide pockets, and pit zips. And it was a fantastic wind shell for that reason alone. And nobody really makes anything like that anymore.
Right. People are, there's a feeling out there that if you have high MVTR in your fabric, you don't need pit zips.
Right.
It's erroneous.
Yeah, for sure.
Stephen, I want to wrap up by giving you two different scenarios to offer your expertise on. The first one is, let's say that you are doing a high output activity, climbing a slope or have a heavy pack above tree line, say in the Rockies. It's cold and windy, and you're getting maybe a 20 to 30 minute rain shower blowing in. So that's scenario number one. And then scenario number two is you're below tree line on the East Coast. Let's call it maybe Tennessee, late fall. It's 50 degrees and it's raining all day. So what are your two best case moisture management scenarios for each of those?
I would wear a hydrophobic base layer shirt.
Just for each one, for across the board, or
scenario? Let's talk about being in the rain all day.
Okay.
I think I'd want to go with a hydrophobic shirt with pretty good permeability and the highest possible MVTR shell over that, and similar rain pants made out of the high MVTR shell. That's 50 degrees. So you're not going to need much insulation. So I think, a fairly thin layer on top is probably all you need for insulation. And then you want that high MVTR shell, and you probably will have to have pit zips or pit zips and pocket zips, which you're not going to find. And I think I think that's as good as you can do. Mm-hmm. And if that's not controlling the moisture that you're accumulating inside, and that's the best you can do, you're going to have to slow down to control moisture. So, to think that you can maintain a given activity level always is a road to disappointment. There will be times where you will have to slow down if you want to control moisture. But if you wear a hydrophobic base layer, it's not going to wet out. And if it accumulates any moisture in the fibers, it'll dry out very quickly as soon as it has the opportunity. And wearing that hydrophobic base layer will give you a better opportunity for evaporation of moisture to happen at skin level rather than somewhere farther out, which means that you won't be sweating as much because your body will be making the most efficient use of the sweat that it's producing. All right, so your second scenario, where it might be raining in 30 degrees, or it's above 30 degrees because it's raining, I would be, so what I would wear in that case, I'd have the hydrophobic base layer, and then for insulation, I would use Alpha Direct, an Alpha Direct garment for insulation, and then I'd have my shake dry shell, or the highest MVTR shell I can get with ventilation, with pit zips that can open. And I can tell you from experience that in your above tree line scenario, I'm going to be very comfortable wearing that clothing, and it's all very light.
I really appreciate all the insight you've given, Stephen, regarding testing and performance and comparing some of these test methods and just looking at layering as a system for maintaining comfort. It's not all about keeping the rain out or allowing the sweat to pass through the membrane. And there's so much going on here between ventilation and fit and material types, and trying to puzzle this all together is a really fun challenge for us.
Well, it's one I hope I can continue to contribute to as we go by. I am learning from all of this, and I look forward to sharing what I learn as I continue doing these experiments.
Definitely, and we really appreciate your contributions to our community. They've been incredibly valuable.
Thank you.
All right, that was a great conversation, and my big takeaway from it is that is an argument in favor of a fully featured jacket.
I love the idea of where waterproof breathable fabrics are going. They're going lighter. And if you don't have the need for durability, if you don't do any rock scrambling or bushwhacking and you're just trail hiking, and you can get away with something like, I always think of the Enlightened Equipment Visp and the Z-Pax Vertus jackets. So they're 7D fabrics laminated to very breathable membranes. They're really comfortable to wear because the fabric is so light. And when it's not raining, you can stuff these things in your pack, and they only take up, 4 to 6.5 ounces or so, depending on the size. And I love that concept. If we take it a step further and say, okay, we've got a 5-ounce rain jacket, and now we can add pit zips or ventilated pockets or, features that add ventilation to it that could really improve performance of backpackers. and maybe only add an ounce or two so that we can have a fully featured ultralight rain jacket that weighs less than half a pound. To me, that's the holy grail of where this is all going.
Yeah, and Enlightened Equipment added pit zips to their
Yep.
Visp, I think last year or the year before that, and I tested that jacket. I'm very pleased with it. I love the combination of the lightweight fabric, but also the manual ventilation and the fully features. It's to me a great example of how you can go too minimalist and too low featured on your apparel.
Yeah, and one of the shirts that I've worn for decades now, that's a really innovative design, is made by Buffalo Systems out of the UK, and it's the Tech Light shirt. And it has ventilation zips up the sides of the shirt from the bottom of the hem almost up to the pits. And so it doesn't have pit zips, doesn't have a chest zip or anything like that. It's a pullover shirt. And it reminds me of the old Marmot dry clean. So the outer shell is Pertex and the inside lining is a tricot fleece, real light tricot fleece. But you would unzip these side zips and be able to spill an enormous amount of heat. And I always thought a rain jacket with side zips would be the absolute bomb, because now it's something you can wear over your backpack hip belt, and it's not the hip belt's not like inhibiting ventilation anymore, and you don't have to fiddle around with pit zips, which can be kind of complicated in a rainstorm. And it obviates the need, or it eliminates the need to have any kind of chest ventilation, because it's kind of built into that one system. So I always thought hybridizing the Buffalo Tech Light design with a waterproof breathable rain shell would be just the perfect rain shell for me.
Well, we'll see what happens. I want to shift gears just slightly and follow up on our last long podcast where I interviewed some of the people at IDFL. And I just wanted to get your takeaway from that. I can tell you my takeaway, which is I came out of that interview with the thought that if I had to choose between two pieces of insulation, and one of them was a higher quality down, like a 950 down, but untreated, and the other one was like a 750 down, but treated, and they were the same price, that I should choose the higher quality down. That was kind of like trying to generalize my takeaway. So what are your thoughts on that?
I think the treatment of down with a water resistant treatment does reduce the performance. And we still are trying to figure this out. It's not completely understandable. We know that adding treatment to the feathers reduces the fill power of the down a little bit. Mm-hmm. We also know, based on, just me looking at a plumule, a cluster of plumules of down under my microscope and spraying water on it, that the addition of water to regular down does cause it to collapse, but not as much as we think. Down is inherently a hydrophobic material. What causes down to collapse is when you get water inside this cluster of plumules, and then they all kind of glom together. Mm-hmm. Well, guess what? The same amount of water that causes that in regular down also causes it in water-resistant down. So water-resistant down isn't this magic bullet that prevents you from making sure your down stays as dry as possible. The unknown here is condensation, right? This is the killer for down insulation. Is if I spend multiple nights in a row at a cold temperature and my body is releasing all this insensible perspiration that is then condensing into my down bag, that is the main cause of down bag decay over time. And so in that respect, is there a difference between water resistant down and untreated down? I have not observed it in practicality. I have observed it in jackets where you have external moisture, whether it's in the form of rain or snow. And I do think down in a jacket, if it's water resistant down, it probably buys you a little more time. I'm just not convinced that it is effective as they say it is in a sleeping bag for condensation management.
Yeah. Yeah. It sounds like a lot of the testing is sort of aimed at the point of total saturation.
Yeah.
Like they have measured and have proven that water resistant treated down holds up better to like complete if you're dunking your sleeping bag underneath the water. Right. But that's not the situation that in the field 99% of the time we run into. So
yeah, and even in a scenario where your garment is completely soaked. So I'm thinking of, you know, flipping your pack raft and you haven't protected your down bag enough and it gets saturated. So the only option you have is to wring it out. And I've taken both. I've taken garments that have been treated with water resistant down and not saturated them both. And I'll say two things. One, it is phenomenally hard to saturate down anything because of the inherent hydrophobicity of the whole garment. Mm-hmm. So you can put a down jacket in a bucket of water and squeeze it and squeeze it and squeeze it and try to saturate it. It takes a lot of effort. So a lot more effort than I've ever experienced in the backcountry, either in a pack raft flip or a constant rain. Mm-hmm. So again, I'm going to go back to the idea that condensation is the biggest threat to a down sleeping bag versus some type of external moisture event that's going to saturate it. The second thing I'll say is once these two garments are saturated, it is really difficult, if not impossible, to dry them out without direct sunlight or heat source. So unless you've got a clothes dryer in the backcountry that you have access to, or bright sun, hot sun that can help dry it out, you're dealing with a saturated mess anyways, and no amount of water resistance is treatment on the down is going to help the dry time.
All right, well, let's change gears once again and talk about what's new at BPL. You've been cranking away on a rain mitt gear guide, so tell us a little bit about what you've discovered as you wrote this.
We have been studying 16 models of rain mitts over the past couple of years, everything from what's available in the cottage industry to a couple models from Europe to some of the mainstream manufacturers' rain mitts here in the United States. And so we looked at fit, durability, features, breathability, and just decided that, you know, we wanted to treat this subject with some comprehensiveness, because to me, the rain mitt is that item that most of us leave behind because we think, okay, it's just another thing to keep track of. The weather looks warm enough. And is it really that effective? There's been some folks in the community that have challenged the effectiveness of a rain mitt. Mm-hmm. Now, I will say that the times I miss having rain mitts are the times when I've experienced unexpected cold rain and all I have is knit gloves, and rain mitts would have made a huge difference. Mm-hmm. So I want, for me personally, in the summers, I want a rain mitt that is as light as possible and as unnoticeable as possible, because it's going to spend most of its time in my pack. But man, when it's 35 degrees and raining or snowing and windy, and all I've got is a pair of fleece gloves, I want a rain mitt over that. It feels so much better just to have your hands warm and have the dexterity preserved, so that when it's time to do all the fine motor skills you need to engage in for normal backpacking activities, whether it's operating a zipper, opening a snack bag, or lighting your stove, you have hand warmth to be able to do that. Nothing's more miserable than cold hands and then trying to do all these little things. And then my favorite seasons are the shoulder seasons. So spring and fall, that's where I do most of my hiking. And so I want that protection. And, you know, even here where I'm at right now in Colorado, it's the fall. We're recording this in early October, and it's cold and during the days and evenings. And so we've been hiking in the 30s and 40s, and it's windy up above the tree line, you know, at 12,000 feet plus. And having rain mitts over my gloves have been it's been lovely. And I'm hesitant to leave this item of gear behind anymore. So that's kind of my motivation for looking at the market.
Yeah, the psychology of them is very interesting. It is, when you said that, it made me laugh, because they're the lightest item I am most likely to like throw out of my pack at the last minute. Like, I might as well save half an ounce. So can you tell us a little bit about what maybe one or two of the standout mitts that you played around with?
Yeah, so I like to categorize them into trail hiking, incidental use rain mitts, and then something that you're going to wear all the time for more robust conditions. So if I'm looking to have a rain mitt as an insurance item for incidental use, and I'm not bushwhacking or rock scrambling, and I don't need super durable fabrics, then there's a couple that really stand out to me. One is the Enlightened Equipment Visp. It's a long gauntlet rain mitt. It has a wrist adjustment cord. It has a cuff hem closure cord. It fits well. It's made with a very breathable fabric. The only caveat is that it does not have tape seams, but it's easy enough, as easy as seam sealing is, to go in and seal the seams. So it's one of the few mitts less than an ounce per pair that actually has a long gauntlet and keeps the closures at the wrist and the hem closed, because that keeps the mitt in place, and that vastly improves the comfort of the mitt if it just stays where it's at rather than slopping around. So
yeah,
that was one of my
that EE. It's the same fabric as the jacket that we were just talking about, and again, it's what you can do when you're not just relying on the fabric, but you actually take the time to add features as well.
Yep, it's my favorite ultralight mitt if you're really into counting grams. My favorite overall mitt is the REI Minimalist GTX 2.0, the new version. The new version has some reinforcements on the fingertips, on the palm, and on the thumb. And when I was testing the old version, which we included in this gear guide as well, we got some pinholes in the fingertips. And this is a more durable fabric than the EE mitt. And I tend to abuse more durable fabrics knowing that they're more durable, and then just kind of patch stuff as I need to. And I like the REI mitts fabrics. It's a GORE-TEX fabric. It's a 3-layer fabric, so it's comfortable over bare hands, and it's durable enough for incidental things like bushwhacking. I love it as a bushwhacking glove. It's not quite durable enough for regular rock scrambling. So I like that mitt a lot if I want my mitt to last a long time. And then the other standout that I was really impressed with is the Outdoor Research Revel shell mitt. Now this is almost a mountaineering mitt. So I would say it's a step down from that, but it's on the order of 3.5 ounces, long gauntlet, durable fabrics. My favorite feature for bushwhacking and rock scrambling and general mountain travel is that it has a dedicated textured polyurethane fabric on the whole palm. So I had no durability issues with this mitt at all. It was very grippy for ice axes and trekking poles and things like that. And overall, just a really comfortable mitt to wear. It's a bit heavier than the ultralight models, but it was my pick for conditions where you need that durability and perhaps the grippiness of the palm.
All right. Well, there's a lot more information in the gear guide. It's very useful. We'll put a link to that in the show notes for sure. Let's talk a little bit about skills. We've got a new Q&A series at Backpacking Light. You want to tell us a little bit about that?
You bet. We started this in September. We're offering it's an hour-long live Q&A session. It's for members only, but all members, basic, premium, and unlimited, have access to this series. In September, we did layering systems. In October, we did shelter systems. We have another one coming up in November, another one in December. So we're going to do these about once a month, and we'll take a topic. We'll give a keynote presentation that's 20 to 30 minutes. Then we'll take 20 minutes or so of questions about that particular topic. And then if there's time, we'll open it up to general backpacking questions. So it's just a way for us to engage with our membership and talk about really focused topics and introduce people to some foundational concepts so that it can help them understand the topic a little bit. Okay, Andrew, let's wrap it up with that. It was a great episode. I learned a lot from Steven. I constantly am trying to figure out the relationship between the data we see on paper and what we experience in the field. And a lot of what he explained really made sense to me. So just being able to kind of open up this market of research and science and engineering and tie it to actual field performance is super fascinating.
Well, that's going to do it for this episode of the Backpacking Light podcast. The Backpacking Light podcast is advertising free, thanks to the membership fees paid by Backpacking Light members. A BackpackingLight.com membership gives you access to 20 years of archives, forums, and online courses. And don't forget, if you're an unlimited member, you'll get the video version of this podcast for free as a part of your membership. So please consider supporting this podcast and become a member right now at backpackinglight.com/membership.
You can download the show notes for this episode at backpackinglight.com/podcast. And if you enjoyed this episode, please leave us a review. It does help other people find the show.
Thanks for listening to the Backpacking Light podcast. I'm Andrew Marshall.
And I'm Ryan Jordan. And if we can leave you with one parting message, it's this: pack less, be more, because lighter is better. Happy trails, everybody.
So I shoulder my backpack, walk away from